So I have just one question for everyone tonight. How did you get here? And I don't mean how did you get in this auditorium or how were you born or anything like that. I mean the physical stuff, like your body, the material. Where did it come from? How were the chemical elements created? Now, making an element is very hard work. It takes an unimaginable amount of heat and pressure, the sort that we can't really sustain here on Earth. So we're going to need some sort of natural refinery, and that's the core of a giant star. Now, in the core of a giant star, it's 10 times as dense as lead, and the temperatures are in the millions of degrees. This is the condition you need to create new elements from old ones. You can make helium by fusing together. You can make carbon, oxygen, all the way up to iron, but no further. At iron, the process stalls. Even in the biggest and the brightest stars, we don't have the temperature to get any further past that. So we don't have any silver, any lead, any uranium. We just have this big ball of iron in the middle. Okay, so how do we get further? We need the most violent process in the universe, a supernova. In a supernova, we have this ball of iron that gets bigger and bigger, and the pressure gets higher and higher until it collapses in on itself, mashing the iron together. Now here's where stuff starts to get a little bit weird. When it does, you form this gooey nuclear stuff, and it can make all sorts of crazy shapes that we call nuclear pasta. This is some nuclear pasta in front of me. I have the spaghetti phase, which is what we actually refer to in research papers. And when the pressure gets even higher, the spaghetti fuse together, and you can get the lasagna phase as well as many other phases. So the iron has been crushed down into this pasta stuff. But when it does, it leaves behind this void where all the iron used to be. So the star naturally collapses in behind it, bounces off the goo, and then ricochets. A shock wave, an echo that goes all the way through the star in just a few minutes. And when it does, it fuses elements together and then blows them out into the cosmos. We can still see these particles today. They're the potassium in the banana you had for breakfast. They're the copper and the gold that's in the cell phone and in Shayna's golden astronaut. And they're also the calcium that's in your bones. So I study this as a nuclear scientist because, well, this is just what excites me. I want to know how it went from then, billions of years ago, to everything I see in front of me today. So, to summarize, put this in perspective, anytime you pick up a fork or get an X-ray or watch a movie, remember, you're just borrowing the burp of a dying star, eating some nuclear pasta. Thank you.